So you are welcome to today's Gmat class. The question we have to treat is under the topic algebra. It's a difficult question. Let's get started. Now let P and Q be the roots of the quadratic equation. Okay, so this is the quadratic equation. X squared minus a minus 2x minus a minus 1 equals 0. So P and Q are the root of this particular quadratic equation. What is the minimum possible value of P squared? The minimum value of this if P and Q are the root of this equation. So for the quadratic equation capturing the roots, the equation can be written in this form. So x squared minus, since P and Q are the root, P plus Q x plus PQ. So from this equation, we can see very quickly that PQ, P plus Q, which is sum of roots, equals A minus 2. And the product of roots, which is PQ, equals minus A minus 1. Okay. So now the question is asking us what is the minimum value of P squared plus Q squared. Now, what is the relationship between this and let's see. Let's take it. Now, what's the relationship between this value and P plus Q equals A minus 2 and PQ equals minus A minus 1. Now, we know that if you square this, P plus Q, you will get P squared plus 2PQ plus Q squared. Now, in order to turn this into this, we subtract minus 2PQ. So in other words, P plus Q squared, P plus Q raised power 2 minus 2PQ is the same thing as this. So let us substitute the values we have here and see where that leads us. P plus Q is A minus 2, so P plus Q is A minus 2 raised power 2. Then minus, we have 2 here. Then PQ is minus A minus 1. Minus A minus 1. So this gives us A minus 2 squared minus, that is, we open the bracket now, plus 2A plus 2. Okay, so let's open this bracket. So definitely this is going to give us a quadratic equation. So we have A squared minus 4A plus 4. Then that is opening this bracket, then plus 2A plus 2. So this will give us A squared minus 4A plus 2A, that is minus 2A. 4 plus 2, that is plus 6. So in other words, what we need to do now is to find the minimum value of this equation. So let's wipe this other side off. In order to get the minimum value. Now, what we have there is a quadratic equation. If we plot it on an xy plane, it is going to give us a parabola. Now, because the coefficient of A squared minus 2A plus 6 is plus. The coefficient of A squared is plus. That means we have a parabola that is facing up, something of this nature. So if the coefficient of a squared is positive, the parabola will be facing up. If it's negative, it will be facing down. So the one that is facing up is the parabola we are dealing with here. So that is why we have a minimum possible value. So the minimum possible value will be this region. So if this is the xy plane for it, as an example. So the value of y at this point is what we are asked to look for. So let's wipe the graph off and start solving. Now, in order to find the minimum point or the turning point of a quadratic equation, we need to turn this into this form, into the form. Okay, now because I'm using a, let me use, because we have a here, let me use a different letter. Let's say we have, okay, B. I don't want to use A so that you don't confuse it with the A that you have in the equation. So we have B, which is a particular constant here, x minus h squared plus k equals y. We want to write this in this form. So in this form, this shows us the turning point of a parabola, where h is the value of x at the turning point and k is the value of y. So if the parabola is facing down, we are going to be dealing with the maximum point. But because it is facing down now, it's facing up, so we are looking for the minimum point. So the minimum point in this case would be the value of y, which is the value of k. So let's turn this into this form. So the first thing we need to do is, since we have the coefficient of this as 1, so let's just continue from there. Minus 2a. Let's move this to this other side. And then now we find half of this and then square that. Half of minus 2 is minus 1, you square gives you 1. And because we are adding 1, so our intention is to change the form of the equation, not to alter the value. So since we are adding 1 to this, we subtract that 1 from this. Now, we can stop at this. We can discard this value here, this expression, and then move on to this, because this is actually what we need. We are looking for the value of k, which is the minimum possible value of the parabola. But let's just complete it. So if you find this, we have this becomes a squared minus 1. So if you factorize this is what you have, squared plus 5. So we have turned it into this, where b equals 1, h equals 1, and then k equals 5. So definitely the minimum possible value for the parabola is 5. So that makes our answer 5. Now, if you consider this video helpful, you can go ahead and hit the notification button, subscribe to the channel so that you can see more of these videos. Until we meet again next time, so bye bye.